Hello everyone, today we are going to convert the unit system by using dimensional analysis. So after this video you should be able to convert the unit system of some physical quantities. Now let us see how the unit changes. In the picture you can see there are two countries. Suppose I have a box of weight 100 kg in India. Suppose I am sending it to United States. So in United States they use different unit system for weight, and that is pound. So when they measure it, the weight will be 220 pounds. So now out here there is a small problem. So I'm sending 100 and they are getting 220.5. So is the weight of the box increasing while going from India to US? So answer is no. So in order to take care of this change, there is one concept. So the concept is, when you multiply the numerical value and the unit, you will get a constant, a number which do not changes. So when you change a unit system, the numeric value also changes. When you make this 150, the unit becomes something else. When you make this 50, the unit becomes something else, but the product of the numerical value and the unit never changes, it remains constant. So suppose I have two unit system. Numerical value of a physical quantity in first unit system is n1, and suppose the unit is u1, and when you take it to second unit system, let n2 be the numerical value and u2 be the unit. So but we already know, when you multiply the numerical value and the unit, you will get constant. So as both the product is giving constant, I can write n1 into u1 is equal to n2 into u2, and this is the basis of our conversion. Now I can convert this unit system u1 into dimensions. So instead of u1, I'll be writing m1 to the power a, l1 to the power b, t1 to the power c. Similarly, I am changing the unit system u2 into the dimension. So that is m2, l2, t2, and if you put the value, you will get this: n1 into m1 to the power a, l1 to the power b, t1 to the power c is equal to n2, m2 to the power a, l2 to the power b, t2 to the power c. So now if you want to find the value of n1, that is numerical value in unit system 1, you will write n2 divided by m2 by m1 power a, l2 by l1 power b, t2 by t1 power c. If you want to find n2, you can write n2 is equal to n1 m1 by m2 power a, l1 by l2 power b, t1 by t2 power c. So if you're finding n1, you'll write all the 2's up and all the 1's in the denominator, and if you are finding n2, you'll writing all the 1's at the numerator and all 2's at the denominator. Now let us see some of the units in SI system and CGS system. So in CGS system, we measure force in dyne and we measure work done or energy in Erg. And in SI system, we measure force in Newton, energy in joules. Now let us solve one question. So I have to convert 1 Newton into dyne. So out here numerical value is 1 and 1 is 1, so I have to find n2. So the unit of force is Newton, so I'll find the dimension of force. So that is m1 l1 t minus 2. So out here a is 1, b is 1 and c is minus 2. Now I'll compare both the unit systems. So Newton is SI unit and dyne is CGS unit. So I'll compare them. In SI system, unit of mass is kg and length is meter and time is second. So the value of n1 is 1. So in CGS unit, mass is in gram, length is in centimeter, time is in second, and n2 we have to find. Now out of these two unit system, I have to change one unit system so that both of the units are similar. So I'll just convert this kg into gram, that is 1000 gram, this meter into centimeter, that is 100 centimeter, and for time we don't need to change because both are in seconds. So it's not necessary to convert this side, you can convert this also. I would have written 10 to the power minus 3 kg also out here, and 10 to the power minus 2 meter also. So next I'll write the formula. So n2 is equal to n1, all 1s at the numerator and all 2s at the denominator. So I'll put the values now. m1, that is 1000, l1 is 100 centimeter, and t1 is 1 second. So putting values, then you can cancel gram, centimeter, second. You can write 1000 to the power 1, 100 to the power 1, and 1 to the power minus 2, which is 1. So now if you solve this, you will get the value of n2. So that means 1 Newton is equal to 10 to the power 5 dyne. Now let us take another example. So in this question, it is asking 1 calorie is equal to 4.2 joules, and you have to convert this 4.2 joules into new unit system which is having alpha kg, beta meter, and gamma second. So I have to find 4.2 joule is equal to something alpha kg, beta meter, and gamma second. So I have to find this numerical value. So the dimension of energy and work done is same, so I'll find the dimension of work done. Work done is force into displacement. So force is m1 l1 t minus 2, and displacement is l1. So you'll get the dimension of energy or work done to be m1 l2 t minus 2. So a is 1, b is 2, c is minus 2. So now in SI system, mass is kg, length is meter, time is second, and value of n1 is 4.2. And in new unit system, m is alpha kg, l is beta meter, t is alpha second. So here I don't need to convert because both are in kg, meter, and second. So I don't need to change the unit system. So now I have to find n2. So n2 is equal to n1, all 1s at the numerator, all 2s at the denominator. So now I'm putting the values. So this kg, meter, and second will cancel. So I'm left with this. Now I'll put the power inside the bracket. So 1 by alpha to the power 1, 1 by beta to the power 2, and 1 by gamma to the power minus 2. So I'm taking this alpha, beta, gamma up to the numerator. So when you take it to the numerator, the sign of the power changes. So alpha minus 1, beta minus 2, gamma plus 2. So now this is the final answer, that is n2 is 4.2, alpha to the power minus 1, beta to the power minus 2, and gamma to the power 2. So let's take one more example. So if the unit of force is 100 Newton, unit of length is 10 meter, and unit of time is 100 second, what is the unit of mass? So they're talking about a new unit system where force is in 100 Newton, length is in 10 meter, time is in 100 seconds. So we have to find the unit of mass. So we'll use the dimension of force, because in force we have length, time, and mass. So m can be written as force divided by length power 1, time power minus 2, and I'll put the values. Now I'll drop all the units and I'll write the numbers in power of 10. So 100 means 10 square, is 10 to the power 1, and 10 square to the power minus 2. So you will get 10 square divided by 10 into 10 to the power minus 4. I'm taking all the 10s to the numerator, so that is 10 square and 10 to the power minus 1, 10 to the power plus 4. So m is equal to 10 to the power 2 minus 1 plus 4, 10 to the power 6 minus 1, m is equal to 10 to the power 5. So unit of mass is 10 to the power 5 kg. So similarly you can try these questions. So to solve this question you have to use the formula F is equal to G m1 m2 by r square. So from there you can find the dimension of capital G. And don't forget to like and comment.